आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone, let's start with the question. The question says that answer the following. A. What do you understand by sharpness of resonance for a series LCR resonant circuit? How is it related with the quality factor Q of the circuit? Using the graphs given in the diagram, explain the factor which affect it. For which graph is the resistance R minimum? B. A 2 microfarad capacitor, 100 ohm resistor and 8 Henry inductor are connected in series with an AC source. Find the frequency of the AC source for which the current drawn in the circuit is maximum. If the peak value of EMF of the source is 200 volts, calculate 1. Maximum current and 2. Inductive and capacitive reactance of the circuit at resonance. Let's solve the question. A. Now, the circuit would be said to have high sharpness if the current in the circuit drops rapidly as the frequency of the applied AC source shifts from its resonant value. So, the circuit is said to have high resonance or high sharpness if or sharpness of resonance if the current drops rapidly as the frequency of the applied AC source of the AC source shifts from its resonance resonant value. The sharpness of resonance is measured by the quality factor. So quality factor is given by, this is how we measure the sharpness of resonance. The quality factor, which we represent by capital Q in this case, is given by Q equals 1 by R times root of L by C. Now, if we have a look at the graph, we see A, B and C. Now we have to find the value where R is the minimum. We notice that for C, we find the value of R to be the minimum because the current drops the most rapidly in this case. So, for the next part of our question B, now we have a 2 microfarad capacitor, a 100 ohm resistor and a 8 Henry inductor. So we are given L, our inductor value is 8 Henry and our C value is 2 microfarad, which is equal to 2 times 10 to the power minus 6 farads. Now to find the frequency, our frequency is given by the expression or equation frequency equals 1 by 2 pi root LC. So solving this equation for frequency by substituting our values for L and C, we get our frequency as 39.81 Hertz. Now we have to calculate the maximum current. So the maximum current, now we have V naught, the applied potential, as 200 volts. Now at resonance, we have the impedance equal to the resistance value. So I max is given by V naught by Z. Now since we are at resonance, we can write it as V naught by R. So I max is 2 because 200 by 100. We get I max as, now for the second part, to determine the inductive and capacitive reactance at resonance. To determine the inductive and capacitive reactance. This is at resonance. Reactance, we get XL equals XC. That is a condition at resonance. Now substituting this, we get XL as omega L, which is equal to 2 pi frequency L. And then on putting the values here, we get XL equals XC, which is equal to 2 pi times 39.81 times 8, which we find out to be 2 kilo ohms. Now this is the inductive and capacitive reactance at resonance. With this we can conclude our answer. Therefore, for A, R is minimum for C. Alright, and for B, we have frequency equals 39.81 Hertz. For the first one, current Imax is equal to 2 amperes, and second one, our impedance XL equals XC equal to 2 kilo ohms. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।